in the case of the less than, this is the called the left hand. So this is the left tail test. Left tail test. So if we have less than sign, then we call it left tail test. If it has a greater than sign, then we call it a right tail test. This one. And if we have a not equal to sign, then this is called the two tail test. Okay, so here they are shown in pictures. So in this case, when we have HA with mu greater than some value, then we have this situation. Yeah, we will have this situation that and then if we have less than, then we will have this situation. If we have not equal to, we will be in this situation. In other words, the p value here, in this case, the p value will be equal to the probability that z is greater than a, or even we can have equal to sign as well. So in this case, the p value will be p probability that z is less than or equal to a. Okay? So on the left side, and then the two tail test, we will have the p value is equal to the probability that z is less than or equal to negative a plus p z is greater than or equal to a. So this is how we will. Okay, so this what I wrote up there is given here, and so based on that, now once we have the p value calculated, we will now compare it with alpha. So if the p value is less than or equal to alpha, then we say reject the null hypothesis. If p value is greater than alpha, then we fail to reject the null hypothesis. Okay, and interpretation. Well, it depends. Let's do the example and I will show you how to interpret. Okay, first example, a researcher claims that the mean age of women in California at the time of a first marriage is higher than 26.5 years. So what is this? This is the mean age of women at marriage, right? At their first marriage. So if you notice, this is not coming from a sample. So this is your population mean. This is like already existing or already existent number. So this is a population mean. So we can say mu is equal to 26.5. Surveying a simple random sample of 213 newlywed women in California, these researchers found a mean age of 27.0 years. So what is that, 27? Well, it is coming from the the sample of, in this case, 213 women. So this is x bar. Okay, the sample mean, which is denoted by x bar. So I have it here. So the n is 213. Assuming that the population standard deviation is 2.3 years and using a 95% level of confidence. Okay, determine if there is sufficient evidence to support the researcher's claim. Okay, now note here, we pulled down all these, or we got these data or information out of the question, and I put them all here. Now you have seen these things and you have used different formulas to calculate different things. How will you assess that you have to do a hypothesis test in this problem and not like calculate or find the confidence interval or a probability or what else did we do then? Yeah, I think a number of or sample size, to calculate sample size or find the error. Or, how will you decide that? Well, it depends on some statements or some special words in the question. So in the start, if you notice here, this first sentence is saying something about a researcher claims. So the claim word or believes word, that is kind of a hint that it's going towards hypothesis testing. What assures you that this is a hypothesis testing? Well, if it says that determine if there is sufficient evidence to support the researcher's claim, or whoever is making the claim, to support the claim. So then it is hypothesis. Now, is it hypothesis testing for mu or is it for p? That depends again on your understanding of what is mu and what is p. Mu is mean. So if you are if the question mentions mean, then it means we have to do the hypothesis test for means. And if it mentions, it does not mention mean, but it gives us percentages, then it means we have to do it for the proportion. So I have pulled out my data. The further data was that sigma, the standard deviation, is 2.3. The confidence interval, or the level, confidence level or level of confidence, that is C, and alpha is 1 minus C, so 1 minus 0.95 is equal to 0.05. Now I will start by writing my H0 and HA. Okay, so I have my H0 and HA written here, and that is my step 1 actually. Okay, this is step 1, and now for step 2 I am calculating the Z score, that we call it the test statistics. So I am calculating the test statistic, and then which is coming out to be, by the way, 3.17. So now step 3 is to find the p-value. So look here, I made the bell curve here, and then what are we looking at? In order to find the p-value, what type of test is it? Well, this is a right tail test. So that it means we have to look for the area to the right of the 3.17 from the tables, and we found that it is equal to 0.008. Now I'm writing down alpha again here just to see them clearly, easily compare them, and we notice that the p-value is less than alpha. So we reject H0, or we reject the null hypothesis. Sometimes we say we reject H0 in favor of HA. But even if you just wrote we reject H0, that's fine. Okay, next is that we interpret it. So we will say at 0.05 level of significance. Now remember, C is level of confidence, alpha is the level of significance. So at 0.05 level of significance, there is enough or sufficient evidence to support the researcher's claim, because remember, that's what the question asked. It asked, is there enough evidence to support the researcher's claim? So that's what, exactly following or using the words from the question, I can word my answer.